This is lesson 62. We're graphing solutions to inequalities on a number line. And objective 1 is to solve and graph inequalities. Okay, the first thing I want to do is review what an inequality is, even. Okay, before we get to this example, an inequality is just something that's got one of these symbols. Okay, and we should remember what these are. Hopefully this one means greater than. This one means less than. This one is greater or equal. And this one is less or equal. Okay? Greater and less than means the number that we have couldn't be included. So for example, if I wanted a number greater than 1, I couldn't have the answer 1. That number is not included because 1 is not greater than 1. Whereas here, if I want a number that's greater than or equal to 1, 1 would fit that because 1 is greater than or equal to 1 because it's equal. Okay? So these mean the number is not included. This means the number itself is included. So an example, Christina is thinking of a number. If she doubles the number, the product is greater than 4. Okay? Write an inequality for this description and graph on a number line all the possible choices for Christina's number. Okay? So Christina is thinking of a number. So we'll start with n is her number. Then it says if she doubles her number, the product is, okay? So the product means we're going to multiply, and doubles means we're going to take it times 2. So 2 times Christina's number is greater than 4. So we're going to use this greater than symbol here. 4. Alright, so she doubles the number, the product is greater than 4. Well, the first thing we need to do is solve this like an equation. Okay? So we need to get this variable by itself. Well, if I'm taking 2 times the variable to get it by itself, I need to divide by 2 on each side. And we cancel, and we get n is greater than, 4 divided by 2 is 2. Alright, so here's the inequality for the description. It means any number greater than 2 should work. So if I take any number bigger than 2 and double it, the answer should be greater than 4. So for example, if I pick 3 and double it, 3 times 2 is 6. That's bigger than 4. If I take 4 and double it, 4 times 2 is 8, which is greater than 4. But notice, 2 is not a solution, because if I take 2 and double it, 4 is not greater than 4. Okay, it's equal to 4. So the number has to be greater than 2. And we graph inequalities on a number line. The first thing we need to do is make a number line. Okay, a number line is one of these. Now, I always want you, when you make your number line, to put the number you get for your variable in the middle of it. So I'm going to put a little tick mark here and put 2 in the middle. Then I want to number a couple numbers on each side of 2. So I will go 3 and 4 and 1 and 0. So here's my number line. Okay? Now, greater than or less than inequalities, okay, have certain kinds of dots that we had to put. Because when we graph on a number line, we're going to put dots on here. Okay? So, greater than or less than have open dots. Okay? So this is an open dot for those two symbols. A greater than or equal to or less than or equal to have a closed dot. The reason for that is an open dot means the number is not a solution. Okay? And we'll talk about that in a second. So if I say n is greater than 2, that's got the greater than symbol, so I'm going to put an open dot at the number 2. Now the reason why it's an open dot is because 2 is not greater than 2. So this number does not work for the inequality. Okay, because 2 is not greater than 2. And the last thing I need to do is shade toward all numbers that work. So I need to decide which way do I need to shade, to the left or to the right. Well, if I put 1 in and shade this way, this has to work for the inequality. So if 1 is greater than 2, I shade this way. But if 3 is greater than 2, I shade this way. And we should know that 3 is greater than 2. So I'm going to shade this nice and dark so I can see where I'm shading. And I'm going to shade in the arrow here. Okay? So what this means is all numbers over here that are shaded are solutions. So 3 is greater than 2. 4 is greater than 2. 5, 6, so on are greater than 2. So all these numbers work. And we have an open dot because 2 is not greater than 2. It doesn't work. So there's my inequality, and here's my graph for that inequality. Okay, so Christina has a bunch of possible choices for a number. Anything bigger than 2. Alright, let's go into another example. Alright, example 2. Solve and graph the solution to this inequality. First thing I'm going to do is rewrite the inequality. And we're going to first solve this just like we did equations. So I need to get the x term all by itself first. I don't need to change the adding because this is already adding. There's no like terms to combine, nothing like that. No distributing. So I go to get the x term by itself. I'm going to do that by putting a negative 1 on both sides because 1 minus 1 is 0, so that cancels. And 7 minus 1 is 6. Then we need to get x by itself. So I want to get 1x by itself. So I get from 3x's to 1x's by dividing by 3. 1x's I said, I meant 1x. And I'm going to get x is less than or equal to 6 divided by 3 is 2. And here's my solution. And now I need to graph this. So again, I'm going to put my number line here. I'm going to put the number I got right in the middle of the number line, and then put a couple numbers on both sides to fill in my number line a little bit. Now I need to decide open or close dot. This time I need a close dot because there's an or equal to sign. It's going to go at 2. And now this says I need to shade toward numbers that are less than 2. Okay? So if I shade toward numbers that are less than 2, I need to decide is 1 less than 2 or is 3 less than 2. And we all know that 1 is less than 2, so I'm going to shade this way. Again, nice and dark so it's visible. We can see it. And there's our answer. Alright, let's move on to example 3. Okay, example 3 says Vincent goes to the store with $20 to buy a notebook for $4. Okay, so he's going to the store just to get this notebook. He notices that packages of notebook paper are on sale for $2 a piece. We want to write and solve an inequality to show the number of packages of notebook paper he could buy if he also buys the notebook. And we're not including sales tax. Then graph the solution. Okay, well we know Vincent wants to buy two things. He wants to buy notebook paper, he's going to buy a notebook, so we need to know the cost of the notebook. And we know now he's going to buy notebook paper, so we're going to have the cost of the notebook paper. And we're going to add those to see how much money he can spend. We also know that he has a total amount of money. He's got $20. Okay? Now normally we would put an equal sign here to figure out how much he could buy, but he doesn't have to spend $20. Okay? He could spend less than that. He could spend $16, $15, $12, whatever it is. So we're going to put a less than or equal to sign here. Okay? Because he could spend exactly his $20, so we have the or equal to part, or he could spend less than that. He can't go over $20 because he doesn't have that much money. Alright, so it's got to be less than $20 or equal to $20. Well, the cost of his notebook is $4, plus the cost of the paper. Well, we want to know how many packages of notebook paper that he can buy. So we're going to put that equal to a variable. So I'm going to say n equals the packages of notebook paper. So to represent the cost of the notebook paper, I would take the number of packages I bought times how much they cost. Well, they're on sale for $2 each, so that's the cost of the paper. And we're going to multiply that by the number of packages. So 2 times the number of packages that he's going to have. And that's going to be less than or equal to the total. And his total is $20 that he can spend. Okay, so now we need to solve this inequality. Then after that we're going to graph the solution. So I'm going to solve this inequality again. I want to get the x term, or my variable term, all by itself. So I need to get rid of this 4. And this is a positive 4, so I'm going to do minus 4 or a negative 4 on both sides. This 4 minus 4 cancels and leaves me with 2 n's. Keep my sign the same, and 20 minus 4 is 16. So basically what we're saying is the cost of the paper is 2n, so he's got $16 of paper that he can buy once we take out his $4 for the notebook. Well, to find out how many packs he could buy, we're going to divide by 2 to cancel this, and we get 8. So basically what we're saying here is he can buy 8 packages of paper or less and spend $20 or less. Alright, and now we need to graph the solution. So we know he could buy 8 packages or less, so I'm going to make a number line. I'm going to put my number 8 in the middle, put a couple numbers on both sides, and figure out which way to shade this thing. Well, first of all, I need a closed dot because this is an or equal to. That means he could buy 8 packages of paper. If he did that, he would spend exactly $20. Now I need to shade which way. So again, I need to figure out, would 7 be less than or equal to 8, or would 9 be less than or equal to 8? And the answer is 7 would be less than or equal to 8, so I'm going to shade this way nice and dark. And there's the graph for the solution. Okay, now notice all these inequalities we've done, things I'm paying attention to here when I graph them. I put my number line with my solution part in the middle. I need to pay attention. Do I need an open or a closed dot? Okay, and I talked about how to do that. And then we need to figure out which way to shade as well. So there's a lot going on here when we graph these. And let's go on to our final example. And now we're going to solve and graph the solution to this inequality. So the very first thing you're going to see when I rewrite this is that we're flipped around here. Okay? Now a lot of you guys wanted to, when we had equations, just go ahead and flip this side over here and this side over here to the right. And I told you not to do that, and this is why. Because we can't just do that with inequalities. Okay, so I'm going to solve this just like it looks. But first thing we need to notice is we have subtraction, so we should know that we always change subtraction to addition. And now I'm going to try to get my x term by itself. So I need to get rid of the negative 2's with positive 2's on each side. Because negative 2 plus positive 2 cancels, leaves me with x's over here. I'm going to keep the sign looking just like it is. And 3 plus 2 is 5. Alright? So, here is my inequality. Alright? And I need to graph this. So my solution is at 5. So I'm going to put numbers both ways. Okay, and when I graph this, again, I need to put a closed dot at 5 because of the or equal to sign, and determine which way to shade. So I want to know, this says 5 is less than or equal to x. So 5 has to be less than the numbers I shade. So I want to know, is 5 less than 4, or is 5 less than 6? And the answer is 5 is less than 6, so I'm going to shade this way this time. Okay? Now notice this way is the way we usually shade for a greater than sign, but because of the way this inequality was set up, we still had to shade this way even though the sign says less than, because the number is less than our shading. Okay? Well, another way we could have written this is to flip everything around. And by flipping everything around, I mean we take the x and put it on the left, we take the 5 and put it on the right, and if we're flipping the number and the letter around, then the sign would have to flip around too. Okay? So if we're going to flip the letter and the number around, we have to flip the sign around. Now it's up to you. If you think you can handle this and just flipping the whole thing around to help you graph, it's fine. Otherwise, we can leave it like this and still graph logically by saying we're going to put a dot at 5 and shade toward numbers that 5 is less than. And 5 is less than 6 and 7, so I shade this way. And that's your lesson on solving and graphing inequalities. Good luck on the homework.